wrapping things up today, Ramzi Rizk is giving a keynote about a very hot topic, big data. Please welcome Ramzi.
Hey everyone. I want to figure out this clicker first. Awesome. Cool, so it's really, really nice to be here. What? Really, really nice to be here. My name is Ramzi. I'm one of the founders and CTO of EyeEm, and I want to talk a little bit about big data in photography. So when I talked a little bit to my engineers about the kind of talk that I will be giving here today, they laughed. They laughed really hard when they heard me say big data. And the reality is big data is just a big fucking marketing bullshit statement. One of my favorite movies and one of the funniest scenes is in Pulp Fiction, where John Travolta is on this weird rhetorical argument with Sam Jackson about whether French people call French fries fries or not. And that is exactly it. We don't call this big data, we just call it data. And the reality is that computing power has increased exponentially in the last couple of decades. Processing power, storage power, everything is just going up. And using that power, using that storage, is effectively big data. So what I will be talking about is a little bit more data-driven approaches, and using data to actually create value as well as create an understanding, a deeper understanding, and make some deductions. I will be focusing on photography, but before we get into that, there are millions of examples of people working with big data. The Obama campaign for the last re-election, they predicted some returns up to a fraction of a percentage point just using statistics. I was at a month and a half ago, I was actually in Venice co-writing the policy paper on EU smart cities. The main topic there was data. How to use data in cities, how to make data available to the public so that they can, transparency and so on. And if you look at a lot of the bigger companies, the more famous companies in this space, if the slide will show up at some point, Palantir is one of the lesser known, most successful tech startups in the world, a multi-billion-dollar company, and their job is they can actually detect terrorist attacks before they happen. They can track insurgent movements, they can make predictive analysis, and they're hired by the CIA, by the militaries of the world to make that for them. Another one that is quite unknown, OpenGov, their client base has an annual customer revenue of around $50 billion cumulative. And what they do is they manage the finances of something like 150 different governments within the US and the region. On a slightly nicer level, a sociologist whose last name I always forget, his first name is Hans, is really famous for making these pretty awesome studies about societies and how societies change and how the health and the lifetime and the life expectancies of people are affected by their education, by their social status, how things have developed over time, and he makes predictions that are actually true quite often. And these are, why go beyond the attendees here? And Jawbone is one of the companies that do a lot with data. Their Fit devices, they're Up and Up 3, they track your sleep patterns, they track your steps, they track your activities, and they actually tell you when you should wake up if you want to go for a morning jog. And this is all really, really fascinating, but to me, what drives me, my big passion is photography. And I guess some people are wondering, how is photo sharing big data? And the reality is, big data can be driven by 3 V's. Volume, which is pure amount of content. Velocity, which is how fast that content is coming in, how fast it's being processed. And variety, which means the kind of content, different kinds of content coming in so you can actually crunch and analyze and so on. And to show you a little bit of what we do or how data-driven we are, let me tell you a little bit about my company first. So, my company's name is EyeEm. We're based in Berlin and San Francisco. We are a photographers network. We're a platform and a community for photographers with a little over 10 million signups across the world. And what we did 4 years ago when we got together, we realized that there's this new generation of photographers that are mobile first or even mobile only. There are people that aren't the traditional sense of, don't have the traditional sense of photography, but they have a different art form that they're creating. And we felt that we could give those people a home. So EyeEm became this new platform for a new generation of photographers that can become better, that can interact, that can learn and meet other photographers, but that can also actually earn money through our marketplace and through our various partnerships with different brands. So we're offering a social network for people where they can earn money, which is pretty awesome in and of itself. And we have a bunch of really cool apps. Feel kind of awkward just jumping around the whole time. Yeah, so we have a bunch of apps, iOS, Android, tablets, and web, which people use to actually interact. But the fascinating thing is how we actually work with the millions and millions and tens of millions of photos that, that are on EyeEm. There you go. So this is a pretty cool art project from back in 2008. This one Dutch artist printed out all the photos that were uploaded to Flickr in a single day and threw them around in a room. And to me, this is the perfect metaphor for what kind of chaos is out there when we think of all of the digital footprint that we leave, all of the content that we post, all of the images that we upload online that just never get seen or that just go into this digital oblivion, digital nirvana. And if you think about it, in 2012, more photos were uploaded in that year alone than in the entire history of mankind. Created, sorry, not uploaded, than in the entire history of mankind. So we're just, the amount of content we're creating is increasing exponentially, and what we're missing is a way to understand that content. What we're missing is the way to find the signal in that massive volume of noise. So that is when we sort of adopted this very ambitious but very simple vision for EyeEm. We want to index the world's photos. We want to understand every single detail about a photo automatically. We want to look at the EXIF, we want to look at the metadata that's in the photo, we want to look at what the photographer knows, who they are, where they're from, who they interact with, what's in the photo, quality of the photo, and we want to make that information searchable and structured, and that is big data. It is very, very difficult to think of having every single photo in the history of the world indexed, keyworded, and made searchable, but without being too arrogant, Google did that for words, so my team was like, we can do that for photos. But before we get a little bit into the details of how we do that, if we rewind a little bit, the fact of the matter is it begins and it ends with 1 pixel. The first digital camera I got was this 640 by 480 pixel, whatever it was, and that is a finite number of pixels. That is not mathematically complicated. This really awesome art installation a year and a half ago took that concept and tried to create every single photo that could ever exist in the history of mankind. So they had a small 15 by 10 pixel, basically screen, and they were just generating randomly every single possibility combination of photos that could create, which means that every single one of your faces could be on one of those photos even though that program has never seen you. It will take hundreds of billions of years, so we will not be here by the time it is done, but conceptually it's pretty amazing. It sort of tells us that, there is the photography, which is you as a creative person seeing something and recording that moment, but there's also the technology of it. There's also the technical aspects of it, which are just as interesting and just as fascinating. Another couple of examples, which to me really played a big role in moving me towards this direction. This was in 2009. A plane crash landed on the Hudson River in New York. I'm sure some of you have heard of this story. And it was all over the news. The pilot, I don't know if geese flew into the engine, and the pilot managed to scramble and really soft land on the river, and people were being rescued. And the most famous photo was taken by some random dude on his old iPhone, posted on Twitter with the caption, "Oh my God, OMG, OMG, plane crashes in the Hudson, on a boat to help." And this is sort of a seminal moment when we think of citizen journalism, when we think of mobile photography, when we think of crowdsourced content. And if you think about it, just a few years prior, it was absolutely unfathomable that someone who snaps a photo somewhere would be able to make that photo go around the world within minutes, retweeted, reposted, shared by every single newspaper. It is really a changing dynamic of how the whole industry works. But the problem is, there were probably 100 other photos that were taken by 100 other people of that exact same scene, of that exact same setting. I keep pointing there, but I actually mean there. And those photos were not discovered. Those photos were not discovered because the technology isn't there, because we still cannot connect the dots. We cannot find relevance and find relationships. And that is the second reason why I am so fascinated by this approach. Oh. The last little story are really two of my absolute favorite photos. The one on the left is a photo by, an iconic photo is what we call it, by a woman named Dorothea Lange. She ran around the US in the 20s and early 10s and took photos of the Great Depression. And that photo is called Migrant Mother. It's a woman with her two kids in some cornfield in California or wherever. And you know, they're struggling, they're trying to make a living, and that photo has become one of the moments that describe the great financial the great financial depression of the 1910s, 1920s. On the right is a photo taken by a photographer called Gilles Saunier on EyeEm. That photo was taken 4 years ago, and it was again a mother and her daughter, and these are Romas as they were being evicted in France. They were being gathered up and kicked out of the country, and it was also a big story. Except that photo didn't make it around the world. And there are two reasons for that. Back in the 20s, when Dorothea Lange was about, not everyone had a camera, so the content was being created was much more limited, and the discovery, of course, was much more limited, but the chances of actually shooting an iconic photo were astronomically high. Whereas nowadays, with billions of photos being taken every day, a photo like that, even though it's really beautifully composed, it's a great story and so on, has very little chance to get discovered. So with that in mind, we sort of set on to figure out how can we understand the photo? How can we really understand everything that's in a photo and surface the relevance of it, surface the story? And if you think of analog photography, I grew up with analog photography. There used to be this little feature where you can burn the date on the front of the photo. And on the back, it used to say Fuji or Kodak or whatever it is that you use to print the film. And more often than less, you would write something on it to actually say, you know, Mom and Dad and me on the beach, 92. And this metadata was all that you had. And this metadata is all that people have to go on when they look at photos from 50 years ago, from 60 years ago. The landscape has changed. And this is where it starts to get really interesting. So a photo that gets uploaded on EyeEm within milliseconds goes through a very, very, very technically complex process. The first step, which is quite simple, we actually look at the EXIF data. We look where the photo was taken, when it was taken, what kind of camera, what kind of focal length, what kind of aperture, so on and so forth. Then we go one step higher and we look at the kind of location it was taken. If I take a photo here, EyeEm will tell me right away that this is a conference, this is a venue, this is Beirut. The weather, the sun, you know, sun is shining, it's 24 degrees, it's late in the evening. This is a conference, this is a tech conference. This is a, you know, Banque de Liban is organizing. These are the people that are attending. It starts gathering all of that data that we have from the various services. But it also tells me, you know, who took the photo, what kind of person, is what age, what demographic, what they tagged the photo with. Are the comments positive or negative? Are the keywords in the photo descriptive or more conceptual? And all of that data just gathers tons and tons of keywords. But this is all data that is really easily achievable. The challenge is understanding what is in the photo. And as any photographer will tell you, the rules to taking a good photo are actually quite simple. There are a few limited rules, in a way. You have the golden third, so you frame things on 1/3 of the photo. You have negative space. You know, one easy tip, if you want to take a good portrait, I guess Dan will disagree, but if you want to take a good portrait, move your topic off-center. Move your subject off-center, the photo will look better automatically. These are really easy things, but the masters are the ones that break these rules. So we can't just measure these things and say, this makes a good photo. This is where big data and a particular field called deep learning comes in. So when we look at a photo, we see a photo. When our algorithms look at a photo, they see this. They don't see people and trains, they see pixels. They see pixels in relation to other pixels, pixels connected to one another, and then the algorithms go and run something like 500,000 to 1 million operations within calculations or measurements in less than a second. These measurements are actually then transferred, and we can extract everything we know about that photo. By looking at that photo, we can extract that there are 2 trains in it, that there's a motion blur, that there are people, that the numbers 2 and 3 are being shown. We can also say this is a symmetrical photo. We can also say this is a beautifully composed photo. We can also say these are similar photos. So suddenly, within a second of a photo being shared, we have hundreds and hundreds, if not thousands, of data points that we can index and search. I just wanted to put that photo in because I uploaded it. It's a photo that I took, and I was kind of proud of. But the point is, it is very basic, and actually the algorithm says this photo is boring. I do think it's my engineers, messing with me a little bit, but the reality is, if we were looking at just the rules of composition, this might be a good photo. But if we're looking at the actual subject, the algorithms, our computer algorithms recognize that there's an ocean, that there's a horizon, that there's a woman with long hair, that she's wearing shoes, that she's sitting, that there are boats, but it tells me this photo is not really that interesting. And that is the fascinating thing. So, the whole point was talking about big data in B2B, in business. So if we take that idea of, we look at a photo and we understand everything we need to understand about it, where do we apply this? Imagine a camera that actually tells you, while you're pointing it, move a little bit to the left. The photo will be better. Or imagine a camera that says, wait half an hour because when the sun goes down a little bit more, that photo will be perfect. Or imagine a camera that can take a photo of some famous landmark and remove tourists from that photo to make it look like you were there at the perfect moment where no one else was. Or a camera that says the most perfect location to take a photo of the port in Byblos is if you go to that particular stone, stand there and point in that direction. Imagine a camera that actually tells you, use a black and white filter on this photo, or zoom out, or if you take this photo, these are some photos that are very similar to that. Cameras can become much smarter. They are still pretty dumb. Imagine, on the other hand, the second really undeveloped and immature app in your phone, your camera roll. If you have to find a photo nowadays, you have to open up and start scrolling. If I ask you to find a photo that you took at the beach last summer, you would probably need to scroll down well, 2 summers ago, you would need to scroll down for a minute to get to that point. Why doesn't your camera roll understand? Why doesn't your search understand that you saying, show me a photo that I took at the beach in Lebanon last July means exactly what I want it to mean? Imagine a camera roll that works like that. Imagine a search that actually understands what you're saying, where you ask it, show me couples on the beach, and you get exactly that. It is really exciting, the stage that photography through big data has reached. And this stuff doesn't really need to be imagined. It's stuff that we're actually working on. It's stuff that we've built. The future is just absolutely fascinating. And it's big, it's searchable, and it's at a point where a machine looks at a photo and understands exactly what that photo is, and the sky is the limit. I would like to open up for questions if you have some time. Otherwise, I would like to thank you and hope you enjoyed the talk. We do have some time.
Yeah, 5 minutes. Any questions?
Ramzi, thank you for the presentation. Aristide Basha. If I'm not mistaken, Google already has some kind of a service that is similar to yours, meaning that you can actually put any picture on Google search and get a lot of info out of this picture. How do you guys compare to Google on this feature? And do you think that Google will be developing more their features and there will be some overlap between what you guys are doing and what Google is aiming to do?
So we're actually in very close touch with Google as one of the companies. There's 4 or 5 companies around the world that are working on a very high level on these problems. And interestingly enough, this computer vision area is a very open and communicative one. So they tend to publish everything they work on. If you're talking about Google search itself, it's kind of a similarity search that's been around for a while. There are some techniques that recognize very small, very concrete concepts. What Google recently brought out is actually a concept understanding. So they can take a photo like this and to a certain extent say people in an audience at a conference. So yes, they are working. Yes, we are, in that sense, in a way, competing. We do have the advantage of owning the creation process. So we don't rely on the keywords to tag and to understand our content, but we do have information like location information, like weather information, like demographic information. So we can tell the difference between a sunset and a sunrise because we know when the photo was taken. So there are some similarities, sure, but there are also quite a few differences.
Just one follow-up question. Since you guys are working on this specific application, any other applications, for example, for medical imaging or recognizing some patterns for like different cancer types, etc. These applications, are you going to work on them also?
I know of quite a few companies that are focusing on actually, for example, anomaly detection in blood and so on and so forth. It's not something that we're going into. We're more in the photography space for now. But the technology is applicable to anything. So it's effectively you're training a model. So if you want to train it to discover other content, you can do that as well. But the advantage of having a community and a network and the other metadata that sort of enriches your content, that is really very limited to the photography space.
We have time for one last question.
Hi, it's Brahim. I need to ask about, you mentioned that the algorithm sees the image as a pixels. Does that mean that each image has its own unique fingerprint, or?
Well, each image does have its own unique fingerprint.
So is it possible that 2 images of different scenes could yield the same fingerprint, digital fingerprints, if I'm saying?
Well, it depends on how you define digital fingerprint. If you mean, will I think 2 images are identical?
Yeah,
then the answer,
somehow like that.
The answer is, on a pixel level, no. On a concept level, yes. Because if you have two photos, both have 2 dogs and a girl walking in a park, then I will actually say this photo and that photo are conceptually identical, but they're not the same photo.
Another question, when you mention deep learning, you're meaning that you're using some kind of natural language processing and big data?
So the question is if we're using NLP and
obviously you're using some kind of machine learning, and that means you're using also natural language processing?
Absolutely. So I was worried about going a little too technical, but yes. So we use a specific field of machine learning called deep convolutional networks to understand the content, to train the models and extract the concepts out of the photos. And on our search engine, we have a lot of NLP happening to understand what you're searching for. To understand that on a beach means the photo was taken at a beach, or to understand that a color is, maybe an identifier of the word. So if you search for red flowers, you're not looking for flowers in red cars, but you're looking for flowers that are red. So yeah, there's a lot of NLP going on in there, sure.
Thank you, Ramzi.
Awesome. Thank you, guys.